All right, hello everybody. We are going to be talking about your periodic table of elements. Now, I want everyone to remember that you need to, when you're going through here, like what's our topic of it or objective here? We're talking about the periodic table of elements, okay? So, as you're going through, make sure that you are writing your questions or your main idea down in the left-hand column. In your notes section, make sure you are doing the indenting. Okay, you want to make it so that your eye can find these notes later on. So the periodic table of elements, big thing we're trying to figure out today is why do we use it? How do we use it? How's it set up? Because right now, a lot of you, I'm sure you look at this and you're like, oh, I don't even know what's going on. That's what we're going to try to fix today. Okay, so we know we've got all our different elements up there. Big thing is that you have of your elements. What I'm worried about you learning here is not what about Aristotle and what he didn't know, but the fact that we have 90 naturally occurring elements, and there are about 28 others that have been created in the lab. We don't find them naturally, okay? You can't just go dig them up. This is what you need to have, elements. That's going under your sort of topic in your left-hand column. That we have 90 naturally occurring elements, 28 others made in the lab. Remember, you can pause and rewind this because I'm going to go kind of quick. We know that all of these together, they make up everything that we have, everything that we know. If you know that, you probably don't need to write it down, do you? On Earth, the most abundant element in the Earth's crust is oxygen. Now, when you're writing something like this down, if you don't know what the word abundant is, you need to look that up or raise your hand, ask. Abundant, there's a lot of it, okay? It's plentiful. The periodic table, you've got a ton of information coming in here. Think before you write it down. If you just write everything down, you probably don't really understand it. Periodic table organizes the elements in a particular way. A great deal of information about an element can be gathered from its position in the periodic table. The big thing a periodic table is doing, what I would write down, is it's gathering and organizing your information or your data about the elements. It's gathering and organizing. So you don't just have everything thrown together. Each thing is put in a particular place for a particular reason. You already know that the numbers work because of the protons, right? Every time we add a proton, it becomes a new element. Okay, so you see the number up there, the atomic number. You don't have two number ones, do you? You only have one. Hydrogen. Elements are organized in the table according to their atomic number. You guys should already know this information. You don't need to write it all down. You might want to know about the fact that it's going to tell us what its state is that it's found in. Okay? That might be something that you don't already know. And different periodic tables could be different. Sometimes the atomic number is up here, sometimes it's down here. The mass is going to be the one that's like a 0.00, okay? We've got our symbol, we've got our name, we've got our atomic number, atomic mass, the state that it's found in, and some of them even tell us the valence electrons. The atomic numbers, you guys should already know this. What does it tell us? It tells us a couple things. It refers to how many protons an atom of that element has. No two elements have the same number of protons. I'm hoping you don't need to write that down because you already know it. We also know in a stable atom, what else does it tell us? What else does it tell us? Something about the electrons. Atomic mass. What's going on? What's that made up? That's the weight of the atom. It's the number of protons with the average number of neutrons. The number of protons with the average number of neutrons. That's what you're finding up on the chart is the average number of neutrons. I would write this part down. Hopefully you already know the first part. You don't need to write it down. But if you're writing down atomic mass in your left-hand column, and you're right, the atomic mass is derived at, what is derived? It's found, okay, by adding the number of protons with the average number of neutrons. We're not watching that right now. All right, hold on for 1 second. Now I'm hoping when you read this Like if this is coming up in class, you'd go atomic mass. I know that. Isotopes. Wait a minute. What are an isotope? So what do you think you need to be writing about here? What do we need to be figuring out? The number of isotopes. Well, what is an isotope to figure that out? Well, most atoms have the same number of protons and neutrons. Some don't. Some atoms have more or less neutrons than protons. These are called isotopes. In your notes, I'd be writing isotopes. Isotopes are atoms that have more or less neutrons than protons. You need to know that. Okay? We're seeing different isotopes of hydrogen here, different isotopes of helium. Okay? Because here's my protons, but then here's my neutrons. One isotope only has one neutron. The other has two neutrons. Is this an isotope? It has the same number of protons. This is an isotope. Okay? Atomic mass. Basically, I want you to know, make sure if you see AMU, that what it stands for. AMU stands for atomic mass unit. If I ask you about the AMU, I'm talking about the atomic mass unit. The AMU is equal to just one proton. One proton balanced out with AMU. And you don't need to write this all out. You just need to know that it is way smaller than even a gram. I don't even know how to count this either. This is hundreds, thousands, millions, billions, trillions. What do we go to after trillions? I can't even remember, okay? So it's a crazy amount that you would need of these together to equal one tiny gram. Symbols. Again, you should know symbols, so it shouldn't be something that you really need to be taking notes on. But if you don't know it, write it down. Now, valence electrons. All of us need to know this. When you think valence electrons, I want you thinking of that outer shell, the last shell of electrons. That is your valence electrons. It's the number of valence electrons an atom has may appear in a square. It may, these squares up here. Valence electrons are the electrons in the outer energy level of an atom. You need to know this. You should know it right away. It's one of those basic facts, like we need oxygen to breathe. Valence electrons, it's the outer shell. These, what makes them so important is the way these different elements come together for compounds is they share. Okay, these are the electrons that are transferred or shared when atoms bond together. That's huge. You need to know this part to know this part. Okay? All right, this is huge, people. This is big. Need you to understand this. You're going to have to look at it a couple times to make sure you understand it. This is sort of your first look at it. We're trying to figure out if we're organizing and gathering data, and that's what we have in this periodic table. How is it organized? We know one way. The number is the number of protons, right? But the elements of the periodic table can be divided into three. How many? Three main categories. Metals, nonmetals, and metalloids. Metals, nonmetals, metalloids. Now, maybe when you're reading this, you know what all of those are. But maybe you're like, what's a metalloid? So you know you're going to need to pay more attention when those notes come up. We see here in this light green, these are our nonmetals. We have one over here. The others are all over here. Okay, almost looks like it's going up a staircase. Your metals, almost everything here is a metal, isn't it? But we also have our metalloids. So, you need to know that the periodic table is divided into these three things. Metals, nonmetals, metalloids. Same as you need to know that the atom is made up of protons, neutrons, and electrons. You're going to need to know these three things. How do we know something's a metal? Metals are good conductors of heat and electricity. They're shiny. They can be ductile, means they can be stretched into thin wires. Metals are malleable, can be pounded into thin sheets. A chemical property of the metal is its reaction with water, which results in corrosion. Corrosion is simply rust. Okay? So metals rust. They are ductile. They are malleable. You see how things that we learned in our last unit are continuing on now? You need to know these things about metals. Nonmetals. Nonmetals are poor conductors of heat and electricity. Nonmetals are not ductile or malleable. Think about a rock here. Solid nonmetals are brittle and break easily. They are dull. Many nonmetals are gases. Okay? What is a metalloid? Metalloids, metal-like. They have properties of both metals and nonmetals. They are solids that can be shiny or dull, but we know they are solids. They conduct heat and electricity better than nonmetals, but not as well as metal. They are ductile and malleable. So you think like if you were doing a Venn diagram, they would have a lot of things in common with metals, wouldn't they? But not everything is the same. So silicon is an example of a metalloid. They have properties of both metals and nonmetals. They are solid. Now, we're going to pause right here because I don't want to go into this next section just yet. But we will get there, okay? This first section, we'll want to see your Cornell notes and see what they look like.